This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Hello everyone, this is Felienne for SE Radio. I'm here today with two guests, André van der Hoek and Marian Petre. Marian Petre studies how people reason and communicate about design and problem solving, and how they use representations in their reasoning. She's a professor of computing at the Open University in the UK, and she holds degrees in psycholinguistics and computer science. We also have here André van der Hoek. He's a programmer who loves to create new tools that help developers be more effective and efficient. He's a professor of informatics at the University of California and holds degrees in business-oriented computer science and computer science. Welcome to the show to the both of you.
Thank you.
Thank you very much. We're excited to be here.
So you just wrote a book about software design, and that book is going to be the core of this episode. We're really interested in what the book offers. But first, I want to talk a little bit about software design, because it's this vague, abstract thing. So I'm curious, what is software design for you?
Well, I think we need to distinguish a little bit between design and designing. So a lot of what we're actually researching is designing and talking about design, not just the design. So we tend to think about design as the thing that governs the plan, the thing that governs the structure and the behavior of the software. But what we're studying is designing behavior, which is how people think about that plan, how they create that structure, how they have dialogues about it, how they move it along, how they innovate, and so on. And so that whole business about design thinking is at the core of what we do.
Yep. I think designing, and the design that eventually is produced, right? So what is design has changed over time as it's a phase in the life cycle, something that we do, it's something that's throughout the life cycle. For us, design is really something that developers do throughout. I'm designing my requirements, right? I'm not just eliciting them, I'm actually designing them with the people that I'm working with. Designing my architecture. I'm actually designing the implementation, I'm designing the test cases. Because the kinds of ways that I'm working are designly ways of working it across all of those. And so what we like to do is actually take all of software engineering, all of software development as a design exercise from beginning to end. And that's kind of the lens that we've been using towards everything that we look at, pretty much.
Interesting. So eliciting requirements is usually, I don't think it's usually seen as a design activity. Does that activity change if you look at it as a design activity rather than as a interviewing, observing, getting the requirements activity?
I think it doesn't necessarily change for everybody, but the awareness of it being a design kind of activity changes what you can bring to it, right? So an element is indeed figuring out, what people have to say and what they think they might need, what they think they might want. But then the other part of it is also we're contributing. We're part of a conversation, right? If you and I are working on a software system and I am interviewing you trying to figure out what you need, it's not uncommon for us to go to the whiteboard and draw something out, right? And at that point, we're actually no longer sort of trying to pry out of your brain what we're doing, but we're collectively shaping what the software system is going to be in the end, right? And so for us, design is a lot about building a plan, but the plan also has some parameters to it. And the key parameter is that once it's realized, it better satisfy the stakeholders, right?
Yeah.
And that's something that you see for design in architecture. That's something that you see for design in buildings. That's something that you see in design for fashion. It's equally so in software engineering. So by putting on that lens, we sort of give everybody the freedom to contribute to what the shape of this software system in the end is.
Yeah, so you're saying we want to give everyone a chance to contribute. Does that also mean you don't see a designer or an architect as a separate role in a team? Everyone, all the developers, maybe even the user interface developers and the database admins, are they all designing? Are they all designers?
They are all participating, right? And I think there's certainly separate roles. An architect is going to shape the structure of the system. That's what they do. They're going to figure out what the main components are. But when you think about the design of the software system, somebody who is designing a piece of the user interface, if they do this wrong, it can seriously influence the usability of the system, right? And how that system is going to be accepted. And I think I'm going to tell a little story because I think that might illustrate it a little bit, right?
We love stories.
So I do like stories. So one of the pairs of designers that we talked to and observed, one was a user interface designer, and that's what they did. One was an architect. And what would happen is, I asked the question, so user interface designer, right? We know the methods that you use, right? You user studies, you interview people, you build personas and everything else. So to what degree are you actually aware of the architecture and vice versa? And it turns out that the user interface person is deeply aware of the architecture because the architecture is distributed. And there are some data that is over here, some data that is over there, and some data that's over here. And in this case, she was aware because there were certain things that she wanted to build. There were certain reports that she wanted to design for the users that she couldn't because it would involve too much data transfer from one to the other. And so that's where constraints from one level of design play in the other parts of design. And so what would happen is she would request, can the architecture be redesigned so I can build this report? And that's why I view everybody contributing to the design, because everybody is in the end making decisions that determine whether in the end the people actually are going to like the software, yes or no, right? And that's an oversimplification whether we're going to like it, but whether it meets the needs, whether the stakeholders are satisfied.
But there's another layer to that, which is that if all of the people involved are doing their jobs effectively, they're thinking about design, they're doing design thinking, whether or not the design is their named responsibility.
So what is that design thinking? Can you give a definition for that?
I don't think it's easy to define it per se, but it's a process of understanding that there is a relationship between the way we understand the problem and the way that we understand the solution, and thinking continually, repeatedly, reflectively about those definitions in that relationship. So, I mean, this is the sort of thing that Michael Jackson was getting at with problem frames, and what we're seeing that played out in is every level of software development, all the way through maintenance, because the question is, hang on a minute, why is code the way it is? Why is this software the way it is? It was this way to solve a set of problems where we had a set of priorities, we made some decisions. Why did we make those decisions? How can we can pull back that rationale to make sense of what's here and how we can improve it or how we can make it do something new or something additional.
You made a brief reference there to Michael Jackson and the problem frames. I'm not sure if everyone in the audience is familiar with that. Can you maybe elaborate?
I'm not sure if I can. So Michael Jackson is an eminent, a consultant and theorist in our area. He also happens to be a visiting professor at the Open University. He's done a number of books about software development, about ways of thinking about software development over the years. And one of them is called Problem Frames. And it is very much about making explicit thinking about the relationship between what we understand the problem to be and what we understand the solution to be. And thinking about solutions in terms of problems all the time as a dialogue.
Great, thanks.
Can I add one bit?
Sure.
So design thinking for a number of people has a somewhat narrow interpretation. So if you think about, especially in the field of HCI and in the field of design overall, design thinking is partly a mindset, and it's partly also a nomer for a particular approach, which is we all pile in a room, we do a whole bunch of brainstorming, and 5 days later, magically, we have a design. That's not how we actually interpret design thinking in our view. Design thinking for us is the mindset inside all of the individuals in the organization, just being aware that the choices we are making always impact what might happen next. And so putting the designer's hat on for the architect is normal because that's what they do, but also for the programmer and also for the person designing the test cases, right? It's what is the impact of what I'm doing on the software.
On the design of the software.
On the design of the software, absolutely. On the behavior and the eventual things that might happen. Maybe I'll try to give another example. Most organizations, when you think of the architect and the designers, they play a key role. I have examples of organizations where individuals who then subsequently had to program something made certain choices, right? So think about, for instance, the report that I need to create that is based on a lot of data that's there. And so I, as a user, press give me the report. And the typical way in which a programmer might actually program this is send a query to the database computes the results, sends the results back. And this is at a local healthcare company. This is the way they programmed it, and they put it in there, then they put it out there, and then guess what happened? There were a lot of records, and so the user pressed the button, and it took a few seconds. And then it took longer, because there were more records. And then they started thinking, okay, so are there different ways of doing it? And then they figured out that, hey, there is a design pattern. Actually, it turns out there is a design pattern where you send a query, you get the first bits of results back, you populate your screen. The user is happy because the screen actually already has results. And in the background, you obtain the rest of the results. So that as they scroll down, you have the seamless experience. And so you've just eliminated 2, 3, 4, 5 seconds of waiting time on somebody. That's not the architect. Right? That's also not the user interface designer. It's a programmer who is making these kinds of decisions. And that's what we're talking about. Can you put your design hat on? Because ultimately the kinds of choices that you make in your program, again, become visible or not to the people that are using it.
Nice. So I think what your book is about is also design thinking, right? So the book Software Design Decoded has 66 ways in which expert designers think. Do you think those 66 tips are everything that you need to know to become an expert designer?
Good heavens, no.
Is it at least part of what's becoming a good designer?
What the book is about is so we've spent decades researching high-performing teams, expert software developers, and other software developers in industry doing real problem solving. And what the book is an attempt to do is to distill the research results that identify the traits that experts have, the behaviors that they display, that distinguish them from the less high-performing teams. It isn't about the technical knowledge that they have, because that's covered elsewhere. It's much more about, in effect, the design behaviors, the design practices they have that keep them reflective, that unite their team around design thinking, that drive them to innovation, and in some ways that mitigate against the kinds of biases that we have in our thinking inherently. So it's distillations of those distinguishing behaviors, practices, approaches that are in the book.
Yeah, it's very much about designing rather than about design.
Yes.
Yes. And to answer your question in a slightly different way, by no means is the book complete. There is a test that we used in the book. And for any insight to be included, it needed to have been documented and studied somewhere in the literature. Right? So rather than this being a book where we said, this is what we think happens, right, which you see in many books, and is great because we have many classic books that are exactly of that nature of, here's a reflection on how I work, Steve McConnell, etc. This book, we wanted to go a little deeper and actually be able to back up with proof, one way or another, evidence, there you go, that these things actually in fact do happen and that it's documented somewhere. And so I have a my poor brother-in-law, he is a software engineer. He develops software. And he said, of course, the first thing I did was put drafts of the book in front of him. And he said, there's another one. Expert software designers, they ship their software. And we kind of know that that's true. But in the end, I had to sort of tell him, well, we can't put this in here because we can't find an actual paper or study that says, here's how this plays out. Here's how we know that this is true, and here's why that matters. So by no means it's complete, but it does get at the core of what it means to think. And I think that's something that has been playing out a lot in the academic literature of studying software designers, all the way going back to the 70s and 80s, of when we start talking about opportunistic versus rationalistic design thinking. We go deep or we go broad. And it turns out those were some of the initial papers, and we've gotten a much more refined understanding since then that actually experts both go deep and go broad, but adjust when they do this, right? So if it turns out that I have a particular difficult issue at hand, they might go very deep very quickly and not sort out the whole problem as a whole. And two examples there, if you think of how Eclipse was developed, Right? It was 4 people piled themselves in a room, much like where we are today, whiteboards everywhere, plus a bunch of computers. And so they talked on the whiteboards, and then they programmed things out. That was going as deep as needed to make sure for themselves that they understood what they were thinking about actually would work. And once they had that, they stepped back and broadened the design to include the other parts. So they focused on a particularly important part of the software that they didn't know for sure they could sort out, and sorted it out as deep as needed. In some other cases, you have to go much broader first, but you have to really understand all the stakeholders. You have to really understand what the needs are. And in such cases, you might not program first. So it depends a lot on the kind of design problem that you're facing, how the experts take their little tool bag and start approaching, figuring things out, start approaching where do I want to make my progress first.
Great. So to summarize, all the tips in your book are all evidence-based. They all come from research, either your own research or other people's research. It's not just things that are your opinion, it's things that are grounded in research. And even though the book doesn't have the list of all the papers, the companion website that we also will link to in the show note has all the background research. So if people are really interested in reading the papers, they can find that on the companion website.
Absolutely.
Cool. So why was this book needed? Because the both of you already mentioned that you've been working on this for a long time. Why now? What was the need?
Well, one of the things that we miss in our discipline is theory. And I think if I've been striving toward anything over the decades that I've been doing research, it's a theory of expertise in software design. So we haven't gotten there yet, but it's an attempt to consolidate what we understand about expertise into one place. Because most of the books that already do that are personal reflections, not evidence-based reflections on what happens in practice. And at the same time, there's an awful lot of literature by other people who are, for example, proposing alternative methods or who have different perspectives that take a very different view on this. And a lot of the literature that comes out, for example, that practitioners object to is prescriptive about methods. And this isn't about prescription. This is just about holding up a mirror to expert practice and saying, what is it that you do? Can we see the patterns across different people? Can we understand what the characteristics are that lead to, ships within budget, on time, no loud brown smells, and try to bring that into some kind of coherence. It also matters to be able to articulate these to help teach them. So one of the nice things, there's an awful lot of taken for granted knowledge in expert practice. If you happen to be in one of those high-performing teams, you probably get integrated into that culture and you learn through experience. But what about for other people? So the notion that you can actually articulate some of this and give people things to think about in their own practice, things to improve, and things to respect in their own practice, because where our hope is that actually lots of people will recognize these things, say, yes, I do that. I wonder if I do it enough, or I could help somebody else do that. That articulation is part of what we're trying to achieve with the book.
Oh, I really like that, because lots of the tips in the book make total sense. Like, for example, one of them is experts keep it simple. You're like, oh, that makes so much sense. Do we even need to write it down? But you're so right. By articulating it, you can also start reflecting on it. Is this simple enough? And who in my team is a little bit better at that, and who might need some help to get at a different level? So even if it seems totally logical, everything that's there, it resonated with me a lot. I see how it's very valuable to have it written down somewhere so that you can talk about it.
I think you actually put your finger on something that's been really interesting, because the book has had a somewhat polarizing response in the sense that there's some people that read it and they go, these are great. I'm going to put I'm going to print them out and I'm going to put them on the wall. They'll help me remember. And then there's some people who say these are obvious. Yeah. Of course, you just put those away. But the interesting thing to us is that when we go into the organizations and we, for instance, observe the developers at work, which is one of the things that we do, right? We'll go in, we'll sit in on a meeting, they're designing at the whiteboard or designing at their screen, or they're having a meeting. And when we observe, it's really interesting that it's the people who say, this is valuable because it helps me remember, that actually have a practice of bringing the kinds of things that you were talking about, like keep it simple, into the conversation. We recently were at a major organization, observed their designers working, and every 5 minutes and throughout the entire conversation, it was is this simple enough? Do we need this complexity? Why are we introducing this? And it was very, very conscious in the conversation of these designers. And we've run some experiments where we've compared expert designers versus novice designers. And when you see the behavior differences, these kinds of questions of keep it simple don't appear in the novice conversations. Even though they're very well aware that they're meant to keep it simple, they get lost in the design itself and they forget to stand there and reflect on what they're doing. And that's the difference that's there. That's why, and again, that's why the book brings a vocabulary out and a way of externalizing the kinds of things that we might be doing. And now to turn that around and bringing that into our meetings. Experts know intuitively to do some of these, but giving everybody the option to do that and everybody the option to actually say, hey, have we thought about the right constraints? Are there assumptions that might be violated later on that we're resting on right now that we should actually resolve right now rather than later? Those are the kinds of lessons, insights, tips in the book that will make a difference if you bring them into your practice.
Yeah, I think that goes back to what Marianne was saying, that some people are in a high-performing team and everything works well, but they don't really know why. And then maybe if they switch teams, they don't know what lessons to take away from a high-performing team. And this might also give some hands and feet to that idea, like, oh, this is what we're doing, this is what we're doing. So if I start my own team, if I start my own company, these are the things that I'm going to take away.
Well, it's interesting because I would actually clarify a little bit that one of the things that distinguishes high-performing teams is they do have these socially reinforcing practices that keep drawing them to design thinking, that keep and as they draw new people into the team, they assimilate them into these practices. And it's very reflective. They talk about them. They think about them. So one of the responses we've had from practitioners in industry about the book is, this is an opportunity for us to talk about design thinking with some of our people who don't know about talking about design thinking. And so they've actually brought us in to use the book to leverage conversations about designing. And to try to use the book as the beginning of a vocabulary about design thinking in software, so that people can begin to talk about how they're going about things, what assumptions they're making, what they do in their process, compare it with other people, and begin to build a culture of design thinking that isn't just isolated people going away and coding quietly, or pairs going away and falling into their particular practices, but are about building a much more general view on thinking about design.
I think a final thought maybe is, there's also a lot of folklore and myth around expert designers, right? So if you've been around for 30 years and you've built all the experience, then you're an expert. And naturally, you're a gifted designer versus naturally you're not. The book gives sort of a glimpse at that some of those pieces might not be true. And one of the, again, stories is, when we were doing some of the research underneath the book, we went to a number of companies and said, can we have some of your best architects or designers for a couple hours? And can we have them do design work for a little while? And so we went to one company, did that, went to another company, and then the third company, this really young kid comes out. And so my grad student and I were sitting there, looked at each other and went, the stereotypical, which we made our own mistake, right?
Like, is this the one?
Because really, this is the one? Okay, they gave us somebody because the others must have been busy. And then they started designing and we witnessed and went, it's a piece of beauty. The person knows exactly what they're doing. And so afterwards we talked to him and said, how, right? What happened? He said, well, I made sure in my school that every project I did, I focused on the design component. I took all the classes where I could design some software and I could make lots of mistakes. And so he had it in himself to choose the path that encountered many of the things that are in the book, in some ways consciously and on his own, trying to figure out what was there. And he was an outstanding designer as a result. And the book gives sort of the ability for others to say, where can I put this into practice?
But the other insight is that we tend to think about experts and others as though they are discrete categories. Mm-hmm. And the truth is that experts do not always exhibit expert behaviors, and novices sometimes exhibit expert behaviors, and it's not as discrete as that. So I had a student, Tamara Lopez, who did work on errors and recovery from error during the course of software development. And one of the things that was fascinating was that expert developers with incredible track records were leaving in their code what looked like novice bugs. And the question is, are they idiots? And the answer is, of course they're not. The truth is that they know that what they really want to do is keep focused on their destination and to build something. And they know they have a very well embedded safety net for catching all of those bugs downstream. And so if you look at the broader psychological literature, you find that experts make more slips than non-experts because they don't have to do that continual self-monitoring, because they know that A, they will reach their destination, and having done so, they can do their cleanup process, and that will be reliable. And so there are these interesting artifacts that you get, and one of the really powerful things that's in the book, one of my favorite insights, is about how experts deal with and the attitude to error. So experts make slips, but they're not afraid of making slips. If they find an error in their code, instead of saying, "Oh no," they say, "Ooh, that's interesting. Why is that? Does it occur anywhere else? What might it lead us to understand about our assumptions?" And so they use it as a form of exploration. And then they create an environment around them where the same thing applies. So let's innovate, let's try things, but we also know that we're paying attention, so that if we get it wrong, we'll spot it and we'll be able to fix it, and we'll be able to learn from that. So it's actually one of the surprises has been this business that you don't just assume that if you do this, you will be expert. Or if you don't do this, you aren't expert. But that we see evidence of expert behavior, this kind of reflective, open-minded, innovative practice at different levels. And it's really about the consistency, and it's really about the ability to pull back into the highest standards of design thinking on a regular basis, not about it being there every single second.
So I'm very interested in this story about this young designer that was really good at designing already. It makes me think of what can we do to become better designers. I think what you were saying in the story of that young person, that it's very much about deliberate practice. So he chose exercises that were a little bit above his level, and then he advanced. If you want to be a better designer, how would you do that? Because you're going to learn a new programming language, you can practice on your own with small exercises and you can get better. But suppose I want to take a day a week for a while to be a better designer. What type of things do I deliberately practice?
That's a great question. There's a variety of things that you can do. So one of the things that we know experts do is they actually go look at other systems. And they do exactly what you said. Right? They're doing their business. They're working hard. They're designing things, and then they have a couple of hours and they say, there's this new open source system I've heard about. Let me just go look. Right? And so they go to GitHub and pull down the code, and they study the code for a while. And that's one of the ways in which they broaden the knowledge, and they look at the patterns that others use, and they look at the solution strategies that others use. So that's one part that you can do, is to simply actually examine existing systems. If you are a young student, right, and you want to figure out more, a great way to deal with this is to participate in open source software, right? And it will take you a while. First, you make a little tiny bug fix, but as you become more familiar, it is an opportunity for you to practice, to become maybe closer to the core team, to become a trusted contributor, to eventually maybe become a core team member. We have had a number of students at UCI, in my university, who a number of years back all were contributing to HTTP, the web, Apache, and they sought out, again, the challenge of doing so. And as a result, they have these awesome jobs right now, right? So one of them is now at minor league baseball and re-architecting the entire streaming service, partly because they had the experience of becoming part of the team that did Apache, and partly because one of the other students said, can you fix this little bug, right? And so seeking out how you can challenge yourself in the open source world as a student is one way to do it. And then inside, the commercial world, talk to your manager. Ask for the next design challenge, or ask whether you can witness the team working. Ask whether you can be part of it, because and good managers actually will encourage that, right? They will already walk you down that path to challenge you on that way. But if you don't feel like you're getting enough, you certainly should. Or you should talk to the architect and say, the architect actually has needs. One of the architects that you may know, Rob van Ommering over at Philips, he redesigned the product line for the Philips TVs because they realized that writing the software from scratch from each of the TVs was going to be a little difficult. And so what he designed the product line. But when I talked to him, what did he really do? Well, he took showers, he walked, he used the whiteboard. I mean, all the classical things.
Yeah.
But then he came into the office and said, can you come to the whiteboard with me? And would draw on the whiteboard his architecture. And in explaining, he would learn what he didn't know. But at the same time, if I am the person who he pulls in, I might be learning how he thinks, right? And he did that not once, he did it twice, he did it 3 times. And so there's kind of 2 sides to the story. One is you can put yourself in the position to be somebody who listens, and if you give the right kind of feedback, he's going to pull you in more often.
Yeah.
And the other side to the story is look at the practice that he had, which was to explicitly pull in others and force himself to explain what he was doing, because it is important for you to externalize what's going on inside your head. And the drawings are one thing, but the verbalization of it is another.
Nice. I like it how I could already recognize 4 of your insights from the book in that story. So you had experts borrow for looking at open source, experts collaborate for working together with your team, experts sketch for being on the whiteboard, and experts take breaks for, walking and going in the shower. I really love how the vocabulary of the book is now in my brain, of course, because I read it 3 times over the last week. Now it's very much in my brain. So I'm really feeling that it works. Like, I recognize all these traits, and I could now recognize them in teams or in other people.
Yep. And to just go back to Rob for just a second, in some ways he partly was an inspiration for what's in here, because he was one of the very first people that I talked to and started asking, so how do you do this? Because part of my challenge is I have to teach undergraduates how to design. And at the university, one way in which we tend to do that is we first teach them about requirements engineering in a course, and then they have a document. And then we teach them about the notation of design, so UML or some other notation. And then we kind of send them home and say, go design for a while, and in 3 weeks you hand in your design, and we'll grade it. And I felt deeply unsatisfied about there's nothing I can tell them about how they should behave, what kind of steps they might be able to take. And there are sort of these structured design methods that you can apply, but then you're following a formula, right? And that's not always going to get you where you need to be. So I started talking to people like Rob and others to say, what are you doing? And then starting to ask the question, what can I bring into the classroom, so that the students start understanding what they need to work on. And I just have to tell one, because when you ask about favorites, this totally is my favorite, right? Experts focus on the essence. So experts are not afraid of solving the hard part of the design problem in hand. And if you are in your typical software engineering class and you give a design problem, your students are working on the user interface, the login screen, which database we might be able to use, and they're staying as far and as long away as possible away from where's the hard part, right? And so to be able to now go into my classroom and say, we're going to design the hard part. That's what we're going to do first. And you're going to do that every single time. And eventually they start getting that actually, yes, you're right, because many design problems unfold themselves over time, right? And if I don't get to the unfolding part in time, it's going to be really late night the day before I need to hand in my assignment, right? So that's where the challenge is, and being able to now bring that into the classroom based on everything that we found, that's changing how we're teaching them, and I think that's our ultimate hope, is that kind of teaching can translate to other universities and other places as well, because that's again, when you go back to how can I learn, I think there's also an obligation on us teachers to actually bring this kind of knowledge about how professionals do their job into the classroom.
But there's a resonance with the focus on the essence and innovation as well. So it is understanding that you deal with the hard stuff first, but also if you're going to make an innovation step, you want to make it about that essence, and you want to make it before every other piece that you've designed is going to constrain away your ability to make it differently. And so that shift of perspective and where people put their attention first and where they invest their attention is actually quite important. So one of the observations about experts is experts put a lot more effort up front before they get into implementation, and novices jump into implementation. For good reason. It's fine. It's part of that sort of development of skill. But the understanding that it's okay, we'll have time to write code, but let's think hard about what it is that we want to do. And so if you're watching Teams, we did some work a long time ago on programmers' mental imagery. An awful lot of what's going on is code is pretty much only limited by what people can imagine, right?
Yeah.
We're not limited by physical materials. And even the technology on which we're building is open to our expansion as we develop new technology. And one of the things about mental imagery is how are these people who are extraordinary innovators, what is it that they do in their minds? Where are they putting their attention, and then how are they communicating that? And as I'm listening to André tell the story about the whiteboard and the retelling, that's exactly what happens. So I did a study where I asked people to solve a given problem, and I watched them, and I asked them, I didn't actually ask them to think aloud, but occasionally if they do things that they sit, cross their legs with a pad of paper, and they wave their hand over the pad of paper. Nothing gets written down, or they wave their hand in the air, or they look into the corner of the room and their eyes move. At that point, I would say to them, what do you see? Or what does it smell like? Or what color is it? But what was very interesting is, so they're clearly generating mental images that they are not externalizing in that moment. At the point when it congeals, when it becomes coherent to them, very often, my favorite story is a guy at that point said, excuse me a minute, put his empty notepad down, ran out of the room down the corridor, and said, I've got the solution, and started drawing a solution on the whiteboard. Because what he had done was solve the essence of a problem by analogy. He was talking about an interesting networking problem, and it had to do with how they were making transfers across the wall to make sure that everything that crossed some kind of boundary had the right properties. He draws this up for everybody. Everybody interrogates the design, and then he came back and sat down and said, where was I? Shall we carry on?
Wow.
But that whole business about coming into the hard part, recognizing the resonances in the essential challenges between this trivial problem that I had set him and a problem he was trying to solve in his own work, and then expressing that through some kind of imagery on the whiteboard and starting the design discussion was absolutely classic expert behavior. And then as I studied that team over time, that image was redrawn 100 times and interrogated 100 times and continued to be the focal image for that project, because that was the essence of the solution, even though there was an enormous amount of technical detail that followed from that. And so that business about where people put their attention and that focus on the essence is very, very resonant across the piece.
But of course, if you're a young programmer or a student, it's hard to know what the essence is. I'm thinking of my own project course for first-year students in TU Delft, you give them a problem and they think the hardest part is picking the database. Because they have never solved a problem like this. So part of being an expert and part of solving the hard part first is, of course, also knowing what the hard part is. Is this also something that you can practice, or is that really a matter of experience?
It's partly a matter of experience, because you have to be sensitive to where the complexities in a problem lie. On the other hand, you can practice it. So one of the things that we do in our classes is we go through a whole series of design problems, and they're open-ended, right? But we put them up on the whiteboard, and then I say, so where's the hard part?
Yeah.
And then we have a conversation with the students, and the first one that I put up, they go, what? I said, what? The hard part? What do you mean by the hard part? And I said, well, where do you think you're going to have the biggest struggles to try to sort out what's going on with this particular design problem? And they come up with various suggestions, and then we talk it through, and then we do it again and again and again and again. And that's not a guarantee that they'll understand it for every single problem that comes their way, but they do learn to ask the question.
Yeah.
And that's the important part, right? So rather than, how many design teams have you seen, or how many design students have you seen where you say, let's design this, and they're like, 2 seconds later, they're on the board, they're drawing things, and they have never said, Where's the hard part?
Yeah.
Or what are the goals for this particular meeting? Why are we here? What are the goals for this particular design project? And that's a mindset that you got to change. And that's a mindset, even if you're not a great designer, you can still contribute that design behavior to a team that is working, right? You might be a manager. You might not be the best designer, but you might have a design team that's awesome. And you see them working and you see that they forget to write down the goals. So you can say, look, why don't you write down the goals and the constraints, and then let's design again. And so you can make these kinds of contributions as long as you're aware of them.
Nice, I like that. Of course, there's also some criticism from me on some of the tips.
Please.
So some of the tips seem to be a matter of taste to me. Something like experts prefer elegant abstraction. What is elegant? I'm sure that in a team you have two solutions and the two people in favor of those solutions will say mine is more elegant than yours. Is this a matter of taste or am I wrong here?
Actually, it's ironic. We were discussing this over dinner last night with Brian Randall and Henry Lawson. And we continue to have the conversation about what elegance is. So yes, I believe that the assessment of elegance may be personal. What's typical of experts is the striving for elegance. The understanding that what they want is something that is simple, that addresses the essence, that is clearly expressed, that doesn't add extra, right? So there is a sense of what elegance is. The beginning of my PhD work was try to define elegance with respect to programming languages. I failed utterly, and 30 years later, I still can't give you a definition that I can stand on a soapbox with. But the striving to elegance, to a sense of elegance, I believe is a characteristic of expert behavior.
Yeah, and it might also relate with experts keep it simple, because I think an elegant solution is very much also a simple solution. So these might be in relationship to each other.
Often so. An elegant solution also communicates how it works.
Yeah.
Right. So when you see it, you understand it. You get it.
Yes.
Pipe and filter is sort of the canonical example, right?
Yeah.
Is you see it, once you understand it, it makes complete sense and it's super elegant. And I think that's the kind of thing that experts will strive for.
Also, some of the insights seem to be in conflict with each other. So experts prefer solutions they know versus experts try the opposite. Can we unite these, or are these just insights that apply to different situations?
They're part of your toolbox, right? So often when I describe to teams what's going on is you have a toolbox and you need to pull a certain tool out in a certain situation, right? So experts will borrow existing solutions and designs and software. They will work really hard to do that because they know that designing something themselves is a difficult endeavor. And if somebody has figured it out, and if they can trust it, right? That's a big part of it. If they can trust that software, if they can trust that design, they will use it. However, if they're designing and they get stuck, then they might say, so what would happen if we didn't use and reuse this particular solution and we thought about it differently? So what if we did the opposite of what we just have been doing? So they're very much compatible. They're not goals to achieve. They're tools that you can use to get yourself unstuck, to go in a different direction, to play with the design that you're working on.
So we think of them as complementary because what you're trying to do is work with them, not to tick them off.
Yeah, but that leads to a new, maybe a higher level problem of when to use the right tools. Another of the insight is experts break the rules. So I love breaking the rules, but it's not always a good strategy, and it's then very hard to know, am I on the right path and do I need to break the rules, or should I take into account the constraints that are here and use another solution that I already have? How do experts decide which of the tools to use?
So the first thing I would say is that very often experts break the rules, and the example in the illustration in the book is, let's pretend there's no gravity, as a way to understand the constraints. So there's an example of how they're complementary. But if you think, just step aside for a minute into a much broader view, in most disciplines we learn the rule set, the vocabulary, the syntax, the semantics of the domain first. If you do ballet, if you do judo, if you learn music, the first thing that you do are norms, right? And you learn those and you practice those until you're really in the repertoire. You do your scales, you do your kata, you demonstrate that you understand what these things are and how they are applied. What that gives you is a grounding and understanding, not just what the rules are, but why the rules are the rules, because now you have experience of these things in practice. Then you have the grounds on which to say, okay, I want to improvise now. When might I break the rules and for what effect? So now you understand that your rule breaking is purposeful. It's not just, let's throw all the rules away. It's actually, I want to achieve something beyond what's here, so I'm going to reach out in a principled way. So very often, some of the contrasts are about experts saying, we need something to shift our thinking. A lot of the insights arise from work about the nature of innovation in high-performing teams. What do they do? And they have a whole collection of practices that are about getting them to think imaginatively, getting them to generate ideas, getting them to challenge their own thinking and to reveal their own assumptions. Because you actually have to work pretty hard to do that. And very often it is exactly this stuff that says, let's do something odd. Let's do something shocking for a moment. Or let's just do something that isn't in the normal path of narrowing development. So, and they include things like stepping back and saying, hold on a minute, okay, we've been going down this path, it's all going fine, that's fine, but have we really understood the problem correctly? Now that we've spent some time with it, is our understanding the problem adequate? So let's go back and review that. In the same way as, this constraint is really problematic. We're really not sure what to do about it. This is really taxing us. Okay, throw the constraint away. What would we do then? Does throwing that constraint away give us any insight into how we might address that constraint? Or alternatively, I'm thrashing. I've tried this twice. I'm not getting anywhere. I'm just going to do something else. Because if I make progress in something else, I may again have either time to do some background reasoning about the thing I'm stuck on, or the reconstruction of that something else may give me insight into the thing that's troubling me. So it is this whole sense that you're not just arbitrarily breaking rules. You're not arbitrarily throwing everything away that you know, the patterns, the systems, and so on. It's much more that you're using techniques that allow you to see again or to see differently.
But just to interject, your question is awesome though, because your question is awesome because what the question gets at is, when do I use which of these insights, right? And that we don't know, right? That actually is in so many ways a whole other layer of research that needs to be done. Sort of, how do you recognize a team is stuck, or how do you recognize a design is going in the wrong way, or how do you recognize that we really need another experts on the team? So what the limitation is we've given you a vocabulary, we've given you that tool belt, but you still need to practice using it, right? If I were to give you a tool belt with a hammer and a screwdriver and a bunch of other things, and it said, okay, go build this desk drawer, I'm going to make some mistakes where the hammer is going to hit where the nail wasn't, right? That practice, that level of growing up, you still have to do as a designer, right? It's not like magically you now have 66 insights and boom, I know how to do it. It's you still have to figure out when certain approaches are useful, and that's part of becoming more experienced, right? And that's where we go back to the student or the young kid in the design. That's what they did, right? He had figured out a way to run into all sorts of situations and figure out, if I did this, well, that didn't work, but if I did that did work. And so you still have to learn how to use them, when to use them, because you could use these very disruptively, right? You could be in a design meeting, you could say, 5 minutes into it, are we still having our orientation, right? And did we try the opposite? That's not good. So the sensitivity of recognizing when you need to insert something in a meeting, that's an important part. And we have a fabulous example of a pair of designers who were doing a traffic simulator, an educational traffic simulator, and one of them is a true whiteboard designer. Is on the whiteboard, doesn't use the eraser, uses his hand to erase stuff, is at home. And the other one is more I'll sit back, I'll contribute to it, but was sitting on the chair. And they're designing, and an hour into it, she gets up. The one time she got up and she said, there's a car.
There's a car.
There's a car. And the other designer went, what? And she said, there's a car. And what she meant was, we're building this simulation, and you have been working really hard, but you've not modeled a car, right? And his assumption was, we don't need to model cars. we can actually do this with an aggregate of how many cars are on the road and we'll be fine. And she had figured out that there's a car in her mind. And so finding the timing of that and figuring out when you actually say, hey, you need to reorient yourself. We're missing a part of that. That interplay, that's something, that's a skill that's got to be developed. Because when I look at my undergraduate teams, there's often one of the undergrads who's very vocal and who's designing, and when somebody steps in and says, hey, I think it's slightly different, dismisses that.
Yeah.
And what this person said, there's a car. Okay, let's explore that. And then actually the interesting thing was, for 15 minutes they argued and they said, no, there's a car, yes, there's a car. And then they said, let's table that. Let's design a bunch of other things. And while we're designing these other things, we'll learn whether there should be a car or not. And so that ability to postpone a decision and to disagree for a while and let the rest of the design speak for itself, those are, again, strategies that come with experience. And so the book gives you tools, but it's not a substitute for actually building your experience.
Thanks. So you should do another study to interview people when they're making such a remark. Why did you think this was the right tool to use? That would be nice for
There's a lot more work to be done.
There's a lot more work to be done.
Absolutely.
So what's clearly missing in the book, or what isn't addressed, is different domains. So it seems to be a very generic book about software design. Mm-hmm. I think lots of the tips could also be used if you're designing a building or a chair. It's very generic. But there are differences in a domain. I would say designing an iPhone app is quite different from designing software for a nuclear power plant, for example. Different constraints. Do some of the insights apply to some of the domains? Or do you think the domain isn't important for the design process? It's just another constraint?
Let me try to answer. It depends. So try to answer, because this one is interesting, right? Of course, design in different domains is very different. But it's less so whether it's different in different domains as what is the nature of the design problem that I'm facing, right? So if I'm a software designer for a nuclear plant and I've designed 15 of them, when number 16 comes by, this might actually be a fairly routine design problem for me. And I might go about it in a similar way to an iPhone app designer who has built Flappy Bird and then Flappy Bird 2 and then Flappy Bird 3. And now needs to design Flappy Bird 4, but it's a very similar kind of design that they're doing. And so we might lean on reusing a lot of our existing knowledge, a lot of existing components, making sure that we test things appropriately. So we might go about it actually fairly similarly in those domains. However, if I am new to the iPhone app, right, and I was a nuclear plant designer, and now I need to design an iPhone app, this is very new territory to me. So I'm going to have to do a lot of other kinds of strategies and other kinds of approaches as compared to the person who's done this a bunch of times. So to me, it's less so about whether the domains are so different as it is what the nature of the design problem is that I'm confronted with in terms of my experience, familiarity, and complexity of the design problem that's in front of me.
I'd also point out that even though the different domains have different objects, different constraints, different concerns, the thinking process is still similar. The underlying thinking process still has to do with understanding the problem, understanding your goals, and trying to find appropriate ways to resolve those in terms of the software that you're building. So Andre's talking about normal versus radical design. Whether we can use pattern matching, we actually have to reason through new solutions. And that runs all the way through, because even normal versus radical plays through within designs in terms of the parts we know about and the parts that are new. And so there may well be within the internal parts of designing some problems that are well understood, and you have patterns for that, and so you can just take them for granted, and the ones that are not so familiar, that they may be the essential tough problem that you want to focus on, where you really need to reason about it. And the processes that you bring to both of those are going to be fairly consistent processes. It still comes back to design thinking.
Okay. What do you think about the state of the software industry in terms of design? So are we in a better shape, in a better state today than 20 years ago? Because our industry is changing also from the design perspective. It used to be maybe more waterfall and big design up front, and now we're going to agile.
where we still do some big design up front.
Which is true.
So
what do you think? Are we improving as a community in designing, or do we still have a long way to go?
It's a fabulous question for where we are today, right? So today we are at a conference where some of the luminaries from 40, 50 years ago, 30 years ago are actually here. And some of them were fantastic designers, right? We know them because of the kinds of things that they designed. Today, what I want to say is that the materials we have that are available to us as designers are very different, right? So 40 years ago, you might say people had brick and mortar, and that's what they had, right? Today, we have cement, steel, aluminum, carbon, and we can build skyscrapers. And 40 years ago, we couldn't. So it's the materials, the components that are available, our understanding of how certain components fit and don't fit. That has really changed our ability to design more complex systems, more functional systems, more appropriate systems. We certainly have learned a lot through the experience from 40, 50 years of what are some good design methodologies that we can apply, right? I think Agile is an encoding of, in some ways, many of the practices that we've learned over time that lead generally, not always, but generally to a smoother and better software development process that delivers better what the users might want and might need. But in the end, when you ask, are we better designers? I think that's a really interesting question, right? I think our population of designers has grown a lot. I think there still are, there's a set of outstanding experts that we've been fortunate to work with. But have we really figured out yet to build a practice of apprenticeship, of teaching people how to design, and do that reliably as they're coming through their computer science and software engineering and other kinds of degree programs? I don't think we've succeeded there yet. I do think that as a whole, we certainly advanced the state of what we can work with and our understanding of how we can work with that to build the systems we're building today.
But I think one of the places that we're holding ourselves up is in the relationship between the business models, the business goals, and the software goals. So one of the things that we see in industry is that there are companies and groups that are not effective in practice, but partly that's about the way they've established their goal sets and the way they've established. It's not that the individual developers are not capable of good design. It's that the context in which they're working constrains them away from the long-term thinking, the big picture thinking, the innovation, to immediate immediate results, KPIs, and so on. Yeah. And so we keep bumping into people who feel suppressed by the industry, who feel forced into responsive rather than principled practice because of the constraints under which they're working. And I think that understanding the bigger picture, so for one of the things we see in expert teams, in high-performing teams, is that they are socially embedding the kinds of practices that lead them to good, robust designs, innovation, and so on, right? So they're actually actively building this culture around design thinking and around quality and so on, right? And very often they are fending off an organizational push to behave differently because potentially management, which has become detached from engineering, has read about something and wants to impose it. I mean, so I did a lot of work on UML some years ago, and it was very interesting that even in companies where there was an organizational push to adopt model-driven development, the interpretation of model-driven development in the company varied from team to team. And some of that depended on what authority the team had to do its own thing without being scrutinized by management. And it ranged from people who were wholehearted adopters and were benefiting in the ways they were benefiting, to people who were not actually adopting it because it didn't fit what they were doing, but they were actually kind of putting some documentation together at the end to satisfy management. And it isn't a judgment on the outcomes, but even within companies, if the organizational imperatives are not aligned with and in dialogue with the kinds of development qualities that we need and the qualities of the expert practices, then you might well find things that aren't optimal.
So do I summarize that correct as saying that it's not so much about teaching people to be better designers? The biggest win we have is to change organizations so that there's more room for design thinking?
I think both. I don't think it's an either or. So there's a wonderful paper by a man named David Walker called The Soup That Bowl in the Table or something like that. And his argument is fundamentally this, that you need the soup. You need excellent designers, right? You need the bowl, you need the team that gets them to work together and optimizes them and uses them for what they're good at. And you need the table, the organization that gives them the context in which to operate. And I think we actually need to pay attention to that whole ecosystem, not just to one component on its own.
Great. Well, that's all the questions I have. Thanks a lot for being on the show. Is there anything you wanted to add that we didn't address?
It's the one question you can stump us with.
This is my final question. Did I miss anything?
I suspect we could talk about this for a long time.
Yeah, I think so too.
I'll have one.
Go ahead.
I sort of want to toss out a thank you to sort of all the people that we've been able to talk to,
sure.
Right? And the people that have led us into their organizations. When here's two researchers. We're from the academic world, and they say, can we look at your work for a little while you're working, and we try not to criticize you in the process, but we're going to learn a few things. And the number of practitioners who've just opened up their arms, welcomed us, and said, actually, we would like to talk to you, right? And that's been probably the most gratifying part of it is being able to be in dialogue. And then for me, we wrote the book. Fantastic, great. I'm excited about it. But what I'm much more excited about is being able to go into the classroom, right? And say, here's what I was doing last week when I was at this organization. And here's the kind of stuff we talked about. And this is why it's important that you take this class and what you need to learn and what you need to take away. Especially when in the beginning of the class, I have to tell them, look, you're not going to know what you're going to do because this is design. And in design, things are unknown. And so I'm not going to give you a grading rubric that says if you do this, and this, you have a great grade. You're going to have to trust me in this class that in the end you're going to get a fine grade. But in the middle, I'm going to give you all of the feedback that you would get on the quality of your designs in the real world. And so they score miserable all along the way. But eventually, sort of towards the end of the quarter semester, they start picking it up because they start understanding that actually, he means I really have to think about this, right? And I really actually have to articulate my assumptions. And I really got to solve the hard part. And then 3, 4, 5 years later, to be able to go back and say, how's it going? And seeing them in their organization and then them saying, hey, that was an important class. That is the stuff that I needed to know. That's super gratifying. Yeah. And then to be able to continue that relationship and say, now can I look at your team, right? is that sort of to me, this is an example of how industry and academia can actually work together. We're trained in looking for the patterns. You're doing a fantastic job out there in industry. But together, we can all learn from each other and build up the field as a whole to pay attention to something that is truly fundamental and in some ways still carries with it a lot of mystique, right? Is design is what is this nebulous thing, it's this hard thing. And it's not. It is, but it's not, right? It is, but there are ways of thinking about it. There's ways of engaging with it that if you're conscious about your practices, if you really reflect, that is important. And one of the sort of closing examples that we often use is an expert software designer is in the room twice. So they're there on their own, in the thick of it, designing the thing, and somehow they're there as well, observing all of the dynamics of the team and how they're going about it.
Yeah.
And that interplay of being able to do that and to step into that role in and out, in each of those roles in and out, that's really what distinguishes an expert from somebody who still is making valuable contributions, but can learn some more things.
I think another way of saying that is that one of the really gratifying things about working with industry across countries is how many genuinely reflective, engaged practitioners there are. Okay, I know I have dealt with people in academia who think that practitioners are idiots and they're lazy and they're ignorant, and that is not what we have found. Okay? As I say, there are often organizational constraints on what they do, but by and large, they are not that. And to be welcomed into someplace by reflective practitioners who want a chance to think about what they do and how to make it better, who want to know what other people are doing that they might adopt, even if they only adopt it on their own terms, which is typical, right? There's an awful lot of that going on. And so the key to all of this, someone asked us yesterday, what's the single most important insight that you have? And it's that experts are reflective, and high-performing teams are reflective, and they actually commit proper time and thought to reflection. It's not just lip service.
I would say that's a great end of the show. Thanks a lot. Thanks for being on the show. And we'll make sure all the books you mentioned, and of course also a link to your own book, will be in the show notes so people can read more if they want to.
Awesome. Thank you for having us. It was great.
Yep.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.